Before we start anything, let's think about how we can solve this question. First of all, we need to try to remove the complexity of this function. In this function, the complex part is c squared plus x squared. If we substitute x equals c tan theta, then we can simplify c squared plus x squared as c squared sec squared theta. After that, we can express dx value in terms of theta and change the upper limit and lower limit according to theta variable. Finally, using basic logarithm rules, we can simplify this integral. Clear? Let's jump into the question. Substitute x equal c tan theta. Differentiation with respect to theta. Differentiation of the x value we can write as dx over d theta. Differentiation of the c tan theta value we can write as c into sec squared theta. After that, we can cross multiply denominator value d theta and we can subject dx as c into sec squared theta into d theta. Now we need to change upper limit and lower limit according to theta variable. First one, lower limit. When x equals 0, 0 equals c tan theta. Tan theta equals 0. Tan theta equals tan 0 because 0 value equals tan 0. So, theta should be equals 0. Second one, upper limit. When x equals c, c equals c tan theta. We can cancel out c value, then tan theta equals 1. 1 value equals tan phi over 4. Therefore, theta equals pi over 4. Let's move to integration part. Now, lower limit 0, upper limit pi over 4. Instead of x value, we can substitute c tan theta. Instead of x squared value, we can substitute c squared tan squared theta. Instead of dx value, we can substitute c sec squared theta into d theta. We can get a common factor in the numerator. As well as in the denominator, we can get c squared as a common factor. We know ln AB equals ln A plus ln B. So numerator value we can write as ln C plus ln 1 plus tan theta. In here, simple C value just like simple A, 1 plus tan theta value just like simple B. We know 1 plus tan squared theta equals sec squared theta. Therefore, denominator value we can write as c squared sec squared theta. After that, we can cancel out numerator value sec squared theta and the denominator value sec squared theta. And we can cancel out numerator value simple c and denominator value square term of the c. Denominator value simple c is a constant. So we can bring 1 over c value outside of the integral. After that, we can consider integral sign separately. ln c value is a constant. So we can bring ln c value outside of the integral. Integral 1 equals theta. After that, we can substitute upper limit and lower limit for this theta value. Then we have ln c times pi over 4. This value we can write as pi ln c over 4. Now we need to find integral 0 to pi over 4 ln 1 plus tan theta value. Let's consider this integral as capital J. So we need to find this capital J value. Let's take this value of capital J as equation number 1. We know integral 0 to a fx value equals integral 0 to a f a minus x. In this question, fx value just like ln 1 plus tan theta. Instead of theta value, we can substitute upper limit minus variable. In this case, instead of theta value, we can write pi over 4 minus theta. 1 plus tan pi over 4 minus theta value, we can write as 1 plus tan pi over 4 minus tan theta over 1 plus tan pi over 4 into tan theta. Tan pi over 4 means tan 45 degree. Tan 45 degree equals 1. So, we can write 1 over 1 plus 1 minus tan theta over 1 plus tan theta. After that, we can get a common denominator 1 plus tan theta. We can cancel out numerator value plus tan theta and minus tan theta, and we can get the final result as 2 over 1 plus tan theta. Let's take this value of capital J as equation number 2. After that, we can add both equation number 1 and equation number 2. Then we have in the left hand side j plus j equals in the right hand side ln 1 plus tan theta integral ln 2 over 1 plus tan theta integral. We can consider a common integral and we have ln 1 plus tan theta plus ln 2 over 1 plus tan theta. ln 1 plus tan theta plus ln 2 over 1 plus tan theta value just like ln a plus ln b. We know ln a plus ln b equals ln a times b. So in here we can write ln 1 plus tan theta times 2 over 1 plus tan theta. 1 plus tan theta value just like simple a, 2 over 1 plus tan theta value just like b. After that, we can cancel out numerator value 1 plus tan theta and the denominator value 1 plus tan theta. Now we have ln 2. We know ln 2 is a constant. So, we can bring ln 2 value outside of the integral. After that, integral 1. Integral 1 equals theta. Then we need to substitute upper limit and lower limit for this theta value. Then we can write pi over 4 minus 0. Now 2j equals pi times ln 2 over 4. So j value we can write as pi ln 2 over 8. Let's substitute this value for our capital I value. Then we can write capital I value as 1 over c within bracket pi ln c over 4 plus pi ln 2 over 8. Now we can get 5 over 8 as a common factor. Then within bracket we can write 2 ln c plus ln 2. 2 ln c value we can write as ln c squared. ln c squared plus ln 2 value we can write as ln c squared times 2. Then we have final answer 5 over 8c into ln 2c squared.